right, today we're looking at quadratic systems link sheets, and we're going to have a quadratic system, and we're going to really apply what we've been talking about in regards to our quadratic solving and things like that. So here's our two functions, f of x and g of x. Notice they're both quadratics, highest power of x is 2. And remember, f of x and g of x are just outputs, so I'm going to label them as y's. You can do any part of the link sheet first, but I'm going to solve algebraically first, and since they're both technically equal to y, I'm going to set them equal to each other. So I'm going to write 2x squared minus 5x plus 6 equals negative 2x squared minus x plus 30. Remember your flow chart now. This is a quadratic equation. The top first thing of your flow chart you must do is set it equal to 0. Okay, so you are going to move all of these terms to their side. Add 2x squared, add x, subtract 30. Add 2x squared, add x, subtract 30. Okay, get that? It's now equal to 0. Add those like terms. Remember then to go through the rest of your flow chart. Look for a GCF, whether it's SAM or slide divide bottoms up after that, and set each factor equal to 0. You are going to get 2x values in this case. And remember, when you have systems, once you have your x's, you also have to then go back and get the y's. So once you know your x's, your two x's, you're going to then go back and plug one of the x's in for both of these, get an answer for y, and then take your other x that you got, plug it in for x in either one of the equations. I think f of x is easier to work with, so I'd take each x. Say if x is 10, I put 10 in for each of the x's, and my other x was 20. I put 20 in for each of my x's and get two different outputs out. Okay, so that's my hint for solving algebraically. For the table, I would do the table next, because then once you do the table, you can do the graph. So for the table, all right, 2x squared minus 5x plus 6. Negative 2x squared minus x plus 30. If we graph that, it's not a very good window, and we're going to have to go up higher, so I'll adjust my window. I want my y max. I'm going to try 30. I'm going to try 40 for right now. Oops. See, that's why you gotta pay attention. I changed my x max. Change my y max to 40. All right, now I get a good view. And remember, you're looking for that y value, the lowest y value. So is my first graph that's opening upward. I'll press second table. And now notice my lowest y value for y1 is negative 1, 3. Okay, it's my lowest y value. But I don't have that symmetry on either side. So my lowest y value is here. I don't have the symmetry on either side. And that just means that my true vertex is going to be a decimal in between probably 1 and 2. So that's okay. We're going to probably just put 1 in the middle of our table. So 1 and 3. And we'll put equal points on either side. So 0, negative 1, negative 2, and negative 3. And then 4 to the right, 2, 3, 4, and 5. All right, so 0 would be 6. 13 is negative 1. 24. And 39. And then as I go down, 2 is 4, 9, 18, and 31. So again, the vertex isn't on our table because it's going to be a decimal, but we have the lowest point that we saw on our table, and we'll be able to get a good U shape off of that. Similar idea, now we're looking for the highest because this second y2 is opening downward, so it's an upside down U, and our highest is at here, 0, 30. So I'm going to put 0 in the middle, 30, and then we have equal points on either side. To the right would be 1, 2, 3, 4. To the left, negative 1, negative 2, negative 3, and negative 4. So negative 4 is 2, negative 3 is 15, 24 is negative 2, and negative 1 is 29, and then we have 1 is 27, 2 is 20, 3 is 9, and 4 is negative 6. Now, we could solve this problem, this system, just by looking at the table. And we can solve it by looking for the exact same values. So, for example, this table has the point 39 on it. So does this problem, 39. What other point do they share? That's right, negative 224, negative 224. So guess what? Those are our two points of intersection. Those are our two solutions, negative 224 and 39. That is also what you should have gotten when you solved it algebraically. Negative 224, 39. Again, this link sheet should always kind of be self-checking because you're just getting the answer different ways. And then the last thing we have to do is we need to graph it, and it's a just blank grid. So if I look at my graph here, the graph on my calculator should kind of mirror the graph on my paper. And so I need to get up to at least 30, because if you look on the y's on my tables here, this 39 I could get up to if I wanted to, but definitely need to get to 30. And notice how on my graph I have a lot more positive y values than negative. So that's how I'm going to draw this. I'm going to draw my y-axis, or sorry, my x-axis down here. My y-axis right in the middle. I do need to scale my axes. So for my x-axis, I just need to go by ones because I only need to get to like 5. So I'm just going to go by ones. And here's a negative 1. So always scale your axes. Now for the y-axis, I got to get up to at least 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So if we go by 3s, that would probably be a good amount. So I'm going to do 3, 6, and I'm going to skip that. 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42. All right, so again, if you want to label everything, you can. I just labeled some of them to make my graph less crowded. Then you're going to plot all those points. So I'll do f of x for you guys just so you get an idea. So negative 3 should be 39, which would be right here. Oh, that's negative 2. Negative 339 is right there. Negative 224 is right here. Negative 113. 0, 6. 1, 3. 2, 4. 3, 9. 4, 18. And 5 is 31. So again, what that means is that our vertex it's a U shape. It's just our vertex is going to be a decimal somewhere. So it's okay if it's not as nice as some of the other ones, which is fine. So there's our U shape. It is a U shape. It's graphed correctly, and I'm going to label it f of x. So what you're going to then do is graph the g of x points, label g of x, and again, you should see the intersection. And again, it should intersect at negative 224 and 39. When you are done the graph and solving it algebraically, then answer this question. Can you think of a situation where using a table may not be an effective strategy for finding the points of intersection? All right, good luck finishing this up.